Good morning, students. As you know that today we have to solve the questions related to the inverse trigonometrical function. So I will start your question from 2016, and in your each question paper I have seen from 2016 to 2020 you are getting 2 marks and 4 marks question. Okay, in section A 2 marks question will contain in section A, and 4 marks question will be contained in section B, and previously it is also happening. So now I have taken the first question. It is related to the 2 marks. Tan of cos inverse x is equal to 2 upon root 5. So how will you solve? See here, and I will also explain here two method. First method is related to your property, and second method you can apply by normally you can apply it. So see both the methods, and both are very useful to you, but for the property method is, I feel every time it is very easy. Okay, so see here, tan of cos inverse x is equal to 2 upon root 5. It is given here, and we have to find out here we have to solve for x. The complete question is that solve for x if tan of cos inverse x is equal to upon root 5. Here we have to find out actually the value of x. Okay, only we have to find out here the value of x. So by method 1 I have to write down here the method 1. What is the first method? See, first method is related where you will apply the properties. Okay, you will apply the properties. So see, it's a tan of, we have, you can write here, we have tan of cos inverse x is equal what? 2 upon root 5. Is it clear? Can you tell me cos of cos inverse x is equal what? Cos inverse x. So this tan will be transposed, and in form it will represent in form of inverse. So it is what? Tan inverse 2 upon root 5. Is it clear? Now see here, it's a cos inverse x, and here is tan inverse 2 upon root 5. Is it clear? Listen, I want to tell you here, cos inverse x is equal cos inverse by, that means x will be equal by. So that means if you see here, so if this tan inverse can be in form of cos inverse, yes, it can be possible here. So by property tan inverse x is equal cos inverse 1 upon under root 1 plus x square. We can apply here this property. Is it clear? So this is, suppose it's the equation number A. So here, what is your x? Your x is tan inverse, x is 2 upon root 5. X is what? Tan inverse 2 upon root 5. So this will give you what? Cos inverse 1 upon under root. Actually the value of x is right now 2 upon root 5. The value of x is 2 upon root 5. So this is what? 1 plus x is 2 upon root 5. Here x is what? 2 upon root 5. So x square is what? It's a 4 upon 5. Any issue? No. So it's a 4 upon, actually 1 plus, and x square is what? 4 upon 5. An issue? So now here it's a cos inverse. We can write it under 1 upon under root 5 in the 5 plus 4, it's a 9 upon 5. Or we can write it cos inverse, this root you can write by 1 upon root 9 upon root 5. This root 5 will be multiplied by 1. Okay, so this will give you what? So tan inverse, it's a cos inverse root 5 upon, and root 9 is what? Root 9 is 3. Root 9 is 3. So here we get tan inverse 2 upon root 5. Actually we have changed in tan inverse in form of cos inverse. So tan inverse 2 upon root 5 can be changed in cos inverse is equal root 5 upon cos inverse root 5 upon 3. So suppose this is equation number B. So from equation A and B, from equation A and B, what you get? Cos inverse x is equal tan inverse 2 upon root 5. And what is the value of tan inverse 2 upon root 5? This is cos inverse root 5 upon 3. So from here cos inverse x is equal cos inverse y. This implies this will give you what? X is equal y. So similarly x is equal what? Root 5 upon 3. This is the required value of x. Okay, any issue? Okay, write down. Now I am going to solve next method, method 2. Which you feel that method is simple, you can apply it. Okay. Method number 2. Here we have tan of cos inverse x is equal 2 upon root 5. Okay, so let cos inverse x is equal, suppose theta. Okay, so what is the value of x? X is cos theta. X is what? Cos theta. This is the value of x, and if we are able to find the value of cos theta, that means we can find out the value of x. Okay, so see here, this is equation number A. So from x, from equation A, what is the value of x? The x is cos theta. So this is what? Tan of cos inverse. What is the value of x? This is cos theta is equal to 2 upon root 5. Okay, so can you tell me cos inverse of cos theta is what? It's a theta. See my concept. So tan theta is equal, cos inverse of cos theta is what? Theta. Okay, so what is the value of tan theta? This is 2 upon root 5. And we have to find out only the what? We have to find out cos theta. So now see here, suppose it's a triangle. Okay, and this is your angle theta, and we have it's a right angle triangle I have taken here. Actually these are the trigonometrical ratios. So in for the trigonometrical ratio that we can apply here the Pythagoras theorem. So angle B is what? 90 degree. Tell me what is tan theta? Tan theta is 2 upon root 5. And what is the normal formula? PB HHB. Okay, this is what? P here is what? Tan theta. Tan theta is what? P upon B, means perpendicular upon base. Perpendicular is what? 2, and base is what? Root 5. Okay, so directly I am going to solve. What is the hypotenuse? Hypotenuse is what? Hypotenuse is what? Perpendicular square plus base square. Perpendicular square means 4 plus base is what? 5. Actually root 5 to the whole square is what? 5. So this will give you what? Root 9. Here this is the value of root 9, and root 9 is what? 3. So by this we can find out the hypotenuse. Hypotenuse is what? 3. So can you tell me here from equation number first, x is equal cos theta, and cos theta is what? Cos theta is what? What is the value of cos theta? Cos theta is what? Cos theta is base upon hypotenuse, and base is what? Root 5, and hypotenuse is what? 3. This is the another method. Okay, but here see, actually it normally for the question, for the 2 marks question you can apply it, but for the 4 marks question it is not, you cannot apply this method actually. Clear? in 4 marks question you need to know about the property. Okay, so if your property, if you will start firstly your concept related to property is clear, that means you can apply the method of property for the 2 marks question and 4 marks question. Okay, so like that. See here students, it's a 4 marks question of ISC 2016 question paper I have taken here. Okay, so what is the question is, if sine inverse x plus tan inverse x is equal pi by 2, so we have to prove that 2x square plus 1 is equal root 5. So how will you, every time you will start your proof from whatever is given. What we have, if sine inverse x plus tan inverse x is equal pi by 2, this thing is given. Okay, so now we will start proof. It's a 4 marks question, so we will start from where, what we have sine inverse x plus tan inverse x is equal pi by 2, is equal pi by 2. So can you tell me here, what is the tan inverse x is what? What is the value of tan inverse x? This will give you what? We will transpose sine inverse x. This is what? Pi by 2 minus sine inverse x. Okay, so suppose this is a complete it. So tan inverse x is equal this pi by 2 minus sine inverse x. So what is the value of x? X is what? Tan of this inverse trigonometric, it's an inverse trigonometrical function. If I am asking about the x, so this will change in form of trigonometrical function. So tan of, it's a pi by 2 minus sine inverse x. Will you tell me what is the tan 90 minus theta? Tan 90 minus theta is what? Cot theta. Okay, so now see here, it's your 90 and it is your theta. Is it clear? So 90 minus theta, here theta is what? This is your theta. So x is tan 90 minus theta is what? Cot theta, and theta is what is the value of theta? Theta is sine inverse x. So can you tell me sine inverse, here is a sine inverse trigonometrical function related to the sine. Okay, so can you tell me what is the formula? Listen, where, tell me a single formula where sine inverse x can change in form of cot. So see the formula, it's a here sine inverse x is equal cot inverse under root 1 minus x square upon x. It's a cot inverse. So here sine inverse change in form of cot inverse. These are the conversion properties. Okay, see the papers whatever I send to you. Okay, papers especially for only for the books. See the question, see the papers. Okay, where you see it's a conversion property where sine inverse x is equal cot inverse under root 1 minus x square upon x. So I am going to apply it. It's a what? X is equal cot of sine inverse x is changed in form of cot inverse. So cot inverse under root 1 minus x square upon x. Here is cot and it's a cot inverse. Okay, directly you can don't apply here cross sign. Okay, directly you can write here. So x is what? This has been removed, but don't apply cross mark. So it will give you what? Under root 1 minus x square upon x. Okay, now squaring using cross multiplication is, it will give you what? Under root 1 minus x square multiplied by 1. This will give you what? Under root 1 minus x square is equal, using cross multiplication x by x, it is x square. Now squaring both the side, you will get a 1 minus x square is equal x to the power 4. Okay, so here you will get a 1 minus x square is equal, proof is going on, is equal x to the power 4. So on transposition this will give you x to the power 4 plus x square minus 1 is equal 0. Okay, so let us suppose, let x square is equal by, so by is x to the power 4 is what? By square. Okay, so put the values of x square and x to the power 4 in equation number A. So this will give you what? By square plus by minus 1 is equal 0. Here it's your work. All of you will apply here the Dharacharya formula, and by Dharacharya formula you will get your answer. Okay, here you will get the value of by, and by will be changed in form of x square actually, according to it. Okay, if you face any problem, you can ask to me, okay, in your group, or you can also write on the comment box if you are not able to find this proof. Okay, write down. Hey students, it's a 2 marks question of ISC 2017. Okay, so the question is very tricky. Okay, if your trick is clear here, I will not say your concept, but if your power of understanding is very clear, that means you can solve it, otherwise you cannot solve it. Okay, so see here. Okay, so question is, I am again speaking, we have to prove that 1 upon 2 cos inverse 1 minus x upon 1 plus x is equal tan inverse root x. So how I will solve it? See everything, every step very carefully. We have to prove it. Okay, this portion is LHS and it is RHS. Is it clear? So now see here, we have to write down here the steps. It's the proof. On taking, listen, before taking LHS or RHS, I have to tell you something more. Here LHS is 1 upon 2 cos inverse 1 minus x upon 1 plus x. Okay, and here is what our answer. If I am taking LHS, our answer should be in form of tan inverse root x. Is it clear? How it will happen? See here, see here, which technique I will apply here. Tan inverse root x, when we will get it, if tan square here theta is equal, suppose x, it is clear. So what is the value of tan theta? What is the value of tan theta? Tan theta is root x. And what is the value of theta? Tan theta is tan inverse root x. That means we have to place what? At the place of x we will put tan square theta. Then we can get our, this is the trick. Okay, directly you can solve it. So on taking LHS, here we have LHS is what? 1 upon 2 cos inverse 1 minus x upon 1 plus x. So let, according to what concept, what upon trick, it's a tan square theta plus x is equal tan square theta. You have to put only, don't write this thing. Okay, so is it what? 1 upon 2 cos inverse, and it will give you 1 minus tan square theta upon 1 plus tan square theta. See the concept. 1 minus tan square theta upon 1 plus tan square theta is what? Cos 2 theta. It's 1 upon 2 cos inverse, and it is what? Cos 2 theta. And cos inverse cos, again it will be cancelled. So 1 upon 2, it's an inverse, and here is cos. And your here, if you hide it, your 2 theta, should be belongs to minus pi by 2 to pi by 2 something. Okay, so ignore all the things, you can apply directly. So what is here? It's a cos inverse 1 upon 2 cos inverse of cos. It will be what we have, we have a 2 theta. Is it clear? So 2 cancel out. What we have here is theta, and theta is what? Theta is what? From here you can find out the tan square theta is equal x. So tan theta is what? Root x. So theta is what? Theta give you what? Theta is what? Tan inverse root x. In this way you will get your RHS. Okay, so when you will see your question, your proof, at first you have to think what you have to solve, what you have to prove, and which value you have to put for the x and whatever. Write down. So students, I have taken a question. It is for the 4 marks related to the 2017 ISC question paper. Okay, so the question is, solve the equation for x. We have to find out the value of x again, and sin inverse x plus sin inverse 1 minus x is equal cos inverse x. So tell me, here we have to find out the value of x. Here we can't take the LHS or RHS. Here we did not have to we should not have to prove. Okay, so what? So we have here solution. You will write down solution here. Sin inverse x plus sin inverse 1 minus x is equal cos inverse x. So if you see this portion, it looks like a sin inverse. Here we can apply the property sin inverse x plus sin inverse by, and sin inverse x plus sin inverse by is equal, suppose sin inverse x plus sin inverse by is what? Sin inverse x. Okay, sin inverse x under root 1 minus by square. So 1 minus, what is your by? By is 1 minus x. So this will give you 1 minus x to the whole square. Okay, sin inverse x under root 1 minus by square plus by is what? 1 minus x, and here again under root 1 minus x square. So 1 minus x square. We will apply here the formula of sin inverse x plus sin inverse by. So this will give you what? Now see, it is what? Cos inverse x. Can you change sin inverse cos inverse x in form of sin inverse? Yes, because sin inverse cos inverse x is equal what? Sin inverse under root 1 minus x square. Is it clear? So what at last what we have? We have a x, sin inverse, both are the inverse. Okay, so only we have a x under root, they can be ignorable. So x under root 1 minus x to the whole square plus 1 minus x, and under root 1 minus x square is equal under root 1 minus x square. Is it clear? Okay, so now what can I do? I can transpose this portion. I can transpose it. This will give you what? X under root 1 minus x to the whole square is equal under root 1 minus x square, and minus 1 minus x under root 1 minus x square. So what we can take the common? 1 minus x square is common, root 1 minus x square is common. What we have? We have a 1 minus 1, and it will be 1 minus x. So this will be minus, you will multiply in the bracket. So 1 plus minus 1. So 1 cancel out. What we have at last? We have a x under root 1 minus x square, and here what is going on? 1 minus x to the whole square. So at last we have a x 1 minus x to the whole square. So x cancel out. Is it clear? Squaring both the side, you will get what? You will get a squaring both the sides, what you get? Squaring this term, what we will get? A 1 minus x to the whole square is equal, and what is the square of this? Under square of under root 1 minus x square, so it will give you 1 minus x square. Can you open it? Yes, 1 minus, open it, 1 plus x square minus 2x, and here is what? 1 minus x square. But open it, it's a 1 minus. After opening the brackets, the sign will be changed. It's a minus x square plus 2x is equal 1 minus x square. Okay, so 1 and this 1 both are cancelled here. It's a minus x square and it is also minus x square. Here it is also cancelled. So what we have? We have a 2x is equal 1. So x is what? It's a 1 upon 2. This is the required value of the x. And okay, solve it, write down it. And students, session 2008 questions of session 2018, 19 and 20, I will give it to you home for your homework. Okay, and if you feel any issue with the questions, you can ask to me. Okay, you can send me the pic. I will also send to you the questions related to the 2018, 19 and 20. Okay, and you should also solve the exercises whatever I send to you. Thank you.